Hello everybody. This video may be a little bit long. I'm going to cover a couple of different things throughout a project I'm working on. I am replacing all the capacitors in my 71 Fender twin amplifier. They're all original, so they're well past due of being changed. And these are all the caps laid out in front of me that I'm going to be putting in. You're looking at about $70 worth of capacitors here. These are all Sprague Atom capacitors. Purchased from Mauser in this section here, and I actually purchased this block here from Antique Radio Supply, I believe is what it's called. Tubes and More is their URL, because a couple of these capacitors were actually $7 less a piece, and the other ones were cheaper as well in some capacity. So breaking my order out like this, even though I had to pay shipping on both ends, saved me a lot of money. So I'm going to go through putting this in, showing the amp. Few things to look for. First and foremost, if anybody watches this and they do not know what they're doing, don't do it, or you need to do a lot of research and homework, because these capacitors store voltage for quite a long time, and if you get in there without properly discharging these, you can potentially kill yourself, honestly, die. So be very careful, be very safe, and again, if you do not know what you're doing, take it to somewhere else. But I'm going to throw in some soldering, show a little bit of the soldering on this, since I was kind of referring to that. Some people wanted to see some stuff, so I'll show what I know there in regards to this project, as well as show how well that solder sucker works and just run through it. So let me get moving on here and we'll go. Alright, here's what we're working here. This is a 1971 Fender twin reverb. These are 100-watt amplifiers, crazy loud, and they have two 10-inch speakers in them. These would really be considered stage amps. You know, you can pretty much play on this thing unmiked on the stage and cut through everybody else that's on there, which is a good thing when you can drive it up that loud. It breaks up pretty nice. It's got a nice tone in it for my liking. But the problem is it's not really good for practice. You know, I can't really crank it up even throughout playing in my house or my shop, because this thing is really so loud, you can't stand it. It sounds great, but it's too loud. Now you can buy something called an attenuator that you can hook up behind the amp, in between the amp and the speaker, and you could basically dial your volume all the way up if you wanted to get the tubes to break up, and then set your output of what's actually coming out to you. I don't have one of those. I don't really play much these days anymore, so I'm just doing this to preserve it and make sure nothing happens to it, and I want to play it just a little bit without worrying about anything going wrong. So I'm not going to really get off into the Fenders. This is a silver face. The black faces, the older black faces, pre-70s, 65, 6, 7, somewhere around in there, they're more desirable. You can actually mod these amps and rewire the circuits in them back to the original spec. I'm not going to do that. I'm just going to change things as they are because it sounds good enough for me. Okay, here's a quick shot of the back. I since changed the original blue backs in this to a Celestion G12 M70s years ago. I've probably had this thing 20-25 years. I'm not really sure. Somewhere along those lines. Long time. It's got 4 6L6 power tubes. Like I said, this is a 100-watt amp. You can take out 2 centers or 2 of these outside tubes and effectively run it at 50 watts. But it's still so loud if you try to crank it up. It still will just cut your ears out. So anyway, it's got a speaker out here, your power on, your standby. These are for the reverb and vibrato pedal, which is right here. You can turn them on and off. And then there's a reverb tank down in the bottom of this, and these are the 2 lines that go down to it. Not going to get off all into this stuff, but I'm going to go ahead and play it for a minute, just so you can get an idea on how it sounds right now. Now, I'm not a technical player. I'm a down and dirty banger, so I'm going to play clean through it. I play mostly clean, and the only thing that I would really use is like an old rat distortion pedal sometimes. But I pretty much play clean through the amp. Well, I figured I'd give a quick shot of what I'm going to be playing through it. This is my old Mutt Telecaster that I picked up many years ago from someone who needed to sell it. and it was all calico nasty. I stripped it down and just put some tung oil on it. That's all you see here. I sold all my really expensive guitars a long time ago because you pay so much money for them and it's hard to get past the dings and dents. So I'm down to this one. I did put a Bigsby tailpiece on it. I did a little custom job in here to fit it. Notched all these out. And it's got a Seymour Duncan single coil here. And this is actually a P90 up front instead of the lipstick pickup. So this thing's really fat on the front pickup. That's about it. Nothing special. Just letting you know. You know, typically this three-way switch would be up front. By the nature of the way I play, I have a tendency to slam that switch with my hand, so I turn that around. It just works for me. Alright, well I did a couple test shots with my camera, and it doesn't pick it up worth anything. You know, it certainly sounds better in the room where I'm at. And this is a pretty hot room too, so anyway, I've got the volume on 3, treble on 5, mids on 5, bass on 4.5, and reverb on 3.5, so I'm going to play it just for a minute. No laughing. Something like that, old and rusty. Okay, like I said, it didn't sound too good on the camera. May have been my playing, who knows. Anyway, I have 3 of the power tubes pulled out. Obviously it's unplugged. I'm going to pull the 4th power tube, and these have little clips. You have to push them down with your fingers. You can't see it, but they're in there. I'm just going to wiggle in a tight circle as I'm pulling and work that out of there. And just to kind of help bleed it off, those filter caps, I'm going to turn the standby and the power switch on. And then I'm going to pull the amp chassis out of here. Now when I'm doing this, I'm going to be extremely careful, and none of my fingers or anything are going to go inside this chassis while I'm pulling it out. There is brackets or braces on all 4 corners. And there are these straps right here. I can only show you one. So I'm just going to start pulling these apart. And what's going to happen is that chassis is going to slowly lower down and rest on those. It'll take me a minute to do this. I'm working as fast as I can to try to keep the video as short as possible. So this side of the chassis is falling down right now. And there, it's rested on that. You know, I'm going to tell you guys right now, I'm not a tube amp man, I'm not an electronics man. I just kind of know a little bit about a lot of things, you know. I can do basic R&R stuff, but meaning if anybody's watching this video trying to figure out how to fix their tube amplifier, you might look elsewhere. This is just doing a simple R&R cap kit. And I certainly don't want to give anybody bad advice to where they might inadvertently hurt themselves. I take responsibility for myself if I do something wrong. Just about there. Okay, so there's a big transformer under here. I'm going to hold it there. I still have the preamp tubes in it. I'm just kind of working around those. And sometimes they'll want to snag on the front. You have to start getting them to work out. So now it's starting to come out. And be prepared, these things aren't light. Alright. Like I said, no fingers inside. Alright, now I'm ready to get this up on the bench. Alright, well, I'm going to make sure I discharge and make sure the filter caps on this thing are bled off so I don't get hurt. I'm going to say it again, if anybody is watching this and wants to undertake this, you need a good understanding on what you're doing, or you could potentially kill yourself, to be honest with you. So I've not stuck my hand in the chassis. You never stick your hands in this chassis until it is totally and 100% confirmed that it is dead and those capacitors are not storing a charge. And when you're probing around in an amp under power, or even like this, until it is discharged, one hand only. Sit on the other one, put it in your pocket, put it behind your back, whatever. Don't grab a hold of the chassis and then go in here with stuff and accidentally short yourself out, because it'll run that electricity right through your heart and stop it, potentially. So anyway, I've got one probe here that is actually grounded to the chassis. So I'm going to touch where the filter caps come in. You can put like a maybe a 10K 1-watt resistor in this wire here. I'm doing this just to do it because I know mine are bled off. I checked it with the voltage first and it was already dead. So just to confirm in that, here's my voltage probe. I'm going to come in and look at my meter. 0.04 volts. And it's climbing just a little bit. And these capacitors will charge themselves to a degree. So in this case, what you could do is clip and leave on a lead, and that should bleed anything off that's trying to build back up. It's a good safety deal there. So I can tell right now it's dead on 0 volts. If I remove this lead, now it's slowly climbing up again, but nothing harmful here. It's a percentage of a volt, you know, nothing big. So I need to flip it over so we can get to the filter caps now. The filter capacitors on this amp are located underneath this tray here, this pan. There are 4 sheet metal screws. They're removed. One-handed, I'm going to carefully lift this off, set it aside. Now I still have my voltmeter attached to ground, so I'm going to probe the plus side of these caps and just ensure that I don't have any voltage here. Nothing, absolutely nothing, nothing, nothing. And the one on this side actually is in there backwards, so this will be the hot side. 0.002 volts. So these are absolutely dead. Now I'm comfortable that I can go in there and touch anything I want and not hurt myself. So we're going to get into changing these out. And I'll probably only show 1 or 2 because they're all going to be the same. But I am going to show the solder sucker, and I'm going to start with these caps, get these done, and then I'll flip it over and do the other side. Okay, I'm going to do my best to shoot here and try to clean out this joint right here with this solder sucker. I've got the camera about 4 inches away from where I'm working, so this is going to be very difficult for me to do. I just hope it works out. I'm going to show you a couple different ways to achieve this. I've got everything ready to go. I'm going to come in here and heat this joint up right here and get the solder sucker ready. And it's starting to get molten now. And I'm going to go in here and suck it out. Sorry about the camera there. I'm going to hit it one more time. There's a lot in this ring here. That looks pretty good. So once you get it to that level, if it's still kind of hanging on, I'm going to try to take it out, take this capacitor out by holding the lead and pulling up on it. And there you see I just popped it right out. Another way you could do this is, let's say we'll just clip the lead right here and leave a little bit hanging out. Kind of get your capacitor out of the way. And you could potentially come in here and heat this up and just pull your lead out. See, I just pulled that little section out. A lot of folks leave these things hanging out. If you're already here and you can, do the work cleanly. You know, some people will cut a lead off and then they'll cut the new capacitor lead and solder it to that lead. It's just poor work in my opinion. You know, it's just that. It's just my opinion. So I'm going to, now, since I have that lifted out, then I'll try to come in here and suck a lot of the solder out. There we go. I opened up that hole. You can't see some of the things I can see, but I've opened up the hole just enough and got most of the solder out so I can put in a new lead. Now on these capacitors, just an FYI, typically they'll be marked either with a plus or a minus, but the negative side does not always go to ground. Just keep that in mind if you're doing one of these tube amplifiers. There's some capacitors in here where the plus side goes to ground. So if you're unclear or forget, you might do one capacitor at a time, or take a picture, draw a diagram on how they're in there, if you clip them all out, which one went where. Because these are 20 microfarad 500s, these first three. And then I have two over on this side, which are 70 350s. On capacitors, you try to match it. If it's a 20 microfarad 500 volt VDC, try to get that. Or you need to go up in voltage, never down in voltage. And on filtering caps like this, you can change the microfarads to a degree, and I actually had to do that on mine. The 70 microfarad 350s are a very odd, not made anymore. So I'm going to be filtering at 80 microfarads 450. The voltage is higher than what was in there, and I'll have 10 more microfarads of filtering. So those will be close enough to work. Now I'll do the same on the back sides, and I'm not going to be able to show that. So I'll get this cap out and get this cap out, and then I'll show you how to put it. Okay, I just wanted to do another quick shot. Hopefully you can see better how well this new solder sucker works. Man, I'm really liking it. Just going to warm this up here, get it molten. And it just takes it right out of there. Try another one over here. I went ahead and pulled all the caps out just to save some time for me. And it just pulls it right out. Alright, well I'm kind of doing things in a little bit of a different order than I said. When I'm putting these caps in, I like to put them in to where when the leads are bent and they're down on the board, you can still read the value of them. That will help me later or someone else later. If you bend the leads in a way where the writing is down on the bottom, someone else may not be able to see this later and go, oh, what do I need? And they'll have to take it out, or they'll risk breaking the leads off by trying to twist it around. So another thing is, you can see how I've made a nice lazy bend here, not a tight bend. That's so these won't break off later. Don't just grab it with needle nose and crimp it. You know, so I've just used my finger and just rolled them around. I centered it in between this point and this point and said, okay, that's about what I want right there. And then I bent the leads. Obviously they need to be clipped off. You also want these to sit down on the board. You don't want them hanging up in space, because these amps get moved around. These things might have a tendency to work loose or break over time. So I know this is what I want right here at the very end, plus a little bit. So I'll give myself what I think I need to get through this eyelet down here, and I'll just nip that off. And I'll do the same here. There's the end of it. I'll come down just a little bit and nip it off. So this cap's ready to go in. Now this is the one that was turned in an odd direction as opposed to the other ones. I just know what it was. So now I can go in here and push this cap where it goes. Just like so, and then solder it in. And I'll do one side, I'll let that cool off real good, and then I'll come back to the other side and do it, or I'll do one side, let it cool a little bit, do this side, and then I'll hold it and reheat. You know, just whatever you want to do. So I'm going to lay these in here, and then I'll get back to all the capacitors have been installed, and I'm now ready to solder them in. If you're doing one at a time, you might do this front one first, solder it, let it cool to a degree, go to the back, solder it, let it cool, and then come back at a little bit. You know, if there was a potential that it moved, you might hold it, reheat, and then let it go. So typically when you're soldering, you know, I have my iron here, it's clean. I'm going to tin the tip a little bit, and this is going to act like a heat bridge. Okay, and you don't lay this on the part and feed the solder right into there. You want to kind of feed from the back side. So this is going to be a little bit difficult because of the way all this stuff is laid out, but I'm just going to go in here and heat the components in the eyelet until they get hot and start taking solder. I'm just feeding in, and then I'm pulling out. Now you may not be able to see it, but that was very, very shiny. That means it was hot enough, and now the solder has pretty much cooled. I'll just keep going like this. I'll do all the fronts, and because I have so many joints here, by the time I get back to doing the back side of this one, this will be well cool, so I won't have to reheat anything. You know, so just a little bit for a heat bridge. I'm working really close here, so if I bump the camera, I'm sorry. This is very, very hard to get shots like this when you need to get in here and work. So I hope you guys understand that. So I'm going to try to come back through here and heat it up. And it's taking the solder. And I've got many things in here, so I'm making sure I have all of them hot enough. And there we go. You don't want cold solder joints. If it's not shiny, it almost look like a mirror when you're laying the solder in there and look at it, it's more than likely going to be a cold joint. So I will do the rest of these on the fronts just like I said, and then I'll do the backs of them, and then I'll show you the finished results, and then we'll flip to the other side. Here's a quick shot of the capacitors installed and complete. Now as you can see, like I had stated, you can read every value on these as opposed to putting them in a different order. So, you know, that's just, it's easy to do. Just go ahead and do it if you're going to do something like this. Also, the leads are not long, they're put in proper, everything is in line, it looks tidy, and that's the way the work should be done in my opinion. So everything is also short leaded, so you can hear these are pretty much just sitting on the board. So this portion is finished. You just want to make sure that all your wires are not going to get pinched when you put the pan back on. So now I'm finished with the filter caps, and then we'll do the caps on the inside. I have the amplifier turned over, and I'm getting ready to change all the capacitors on the inside of the chassis. And I had mentioned earlier that typically capacitors, electrolytics like this, they have a polarity, and the negative would usually always go to ground. But that's not always the case. I just want to be clear here. And here's a prime example on these two capacitors where the positive goes to ground. You can't see this, but trust me, it is there. This is the positive side of this capacitor, and that lead goes directly to ground into bias control on this amp. So my point is, always make note of their orientation if you're doing something like this. Don't always make the assumption that the negative on electrolytic cap goes to ground, because in some cases, like this one, it does not. I also kind of wanted to throw in here, which I meant to do on the last clip, is if you have a soldering station with a soldering iron with a base station that has a temperature control on it, you can of course regulate the temperature at the tip of your iron. Now in my case, mine is not. It's just one that plugs into the wall, so whatever temperature it is, that's what you get all the time. But you can regulate the temperature of your tip. And the way I would do that is if I wanted less heat on an item, I would try to use the point of the tip. And if I needed more heat on an item, I would roll it down and get more contact surface on the side of the tip itself and transmit more heat to the part. So you can regulate these. Like if I'm doing PCB work or something like that with a circuit board, maybe changing a capacitor on it, I'll typically use the tip as opposed to more of the side of the iron. So just a little FYI there, you can regulate your temperature even though you may not have a temperature controlled base station. Practice makes perfect. For the sake of time regarding the length of the video, as well as my ability to get in here quickly and change these out, these capacitors, I'm not going to show this, but I'll do the exact same thing. I'll go in and I'll suck the solder out of the leads, I'll change the caps. There's a series of them here, there's one here, and then the two I showed in the last clip. The principle is all the same. I'm going to do the exact same thing in here, and I'll do a quick shot of that, and then this will be ready to put back in and test out. All the capacitors have been installed. It's ready to go back together. You can't really see them in here because they're black, but they are there. Some other things that you might look at if you're working on an amplifier. Number one, before you take it apart or after, either way, turn your volume up a little bit and turn all of your pots, your potentiometers, and listen for any scratchy pots. I've got a couple, 2 or 3 that are a little bit scratchy on here, but I don't have the proper cleaner, so I'll do that later. But if you're cleaning these potentiometers, do not use a contact cleaner. There is a small amount of a lubricant in these potentiometers, so use a pot cleaner. And there's a little gap, you can't see it, but on the back of the pot there's a little gap where the leads are coming out for the wiper. You spray down in there and work them back and forth, and that should clean those up as well as lubricate them. Secondly, you might test your jacks. Some of the jacks in here have a grounding lead on them. I don't know if it will pick up, but here's one for example. When you put your phono plug in there for your guitar, it will undo the ground. It'll undo the shunt from ground. So when you pull it out, there's a little contact here. So pull them in, pull them out, listen to it. It should be fairly dead quiet. If you're getting some humming or some other noises, you might want to check these and bend your leads a little bit. Same goes with the speaker output on this one. Want to check that, make sure that's all good. Aside from that, make sure your ground planes are good, things of that nature. This thing really does look brand new inside. There's no corrosion or anything in it, so I'm going to put it back together and we'll see what we get. Now some folks I know are using like variacs to bring these things up, just kind of make sure nothing is wrong instead of just applying full voltage to it. I don't have a variac, so I know some other folks are using like a light bulb as a current limiter. I'm not going to go through the trouble of that. The amp worked before I worked on it. I'm 100% confident I have everything in here properly, so I'm just going to turn it on and see how it works. Well, alright, it's been put back together. Everything seems to work just fine. I think it sounds pretty good. No oddball sounds or anything like that. It's nice and quiet. I'm pretty sure some of those filter caps were leaking a little bit because it's certainly quieter when I'm stagnant here than what it used to be. I know the camera's not going to do it justice, but hey, you know, it works. So I'll let you hear it now. Sounds pretty good to me. I know it sounds better than I do, but just a little information if somebody was going to attack something like this. Of course, do your own homework. Be safe, so you'll live to hear your amp play. But all in all, I believe this job was successful. Hope this helps. Thanks for watching, guys, and good luck.